Hey guys, how are you doing? How's everything? So, as for this session, we are going to correct the homework starting from page 48 till 52 for speed questions, distance time graph, and speed time graphs. So, as for page 48, the first question. As you can see, the peer sets an experiment to measure the time it takes a ball to fall to the floor from different heights. Look at Pierre's diagram of the equipment. Pierre changed the height each time but always uses the same ball. Now, why do Pierre use the same ball each time? And as I have already mentioned many times, since you have the word same, so you are keeping each and everything in the experiment the same and you're changing only one thing. So you do that in order to make sure that your experiment is fair, right? So this is to keep the test fair, right? Now, the test, what is the measuring device labeled LG? So LG stands for a certain device which is measuring time, okay? And as you can see here in this apparatus or in this equipment in the laboratories, whenever we need to measure very high speed objects like a ball which is falling, we never use a stopwatch. Why? It doesn't make any sense. You can hardly count the number of seconds of the ball falling to the ground, right? So in this case, we usually use the light gates. So LG means the light gate. Okay, now, so these are the results Pierre's find. Okay, the height and the time taken. And now the height means the distance, okay? So you have the distance and you have the time taken. So the average speed is 7.1. Similarly, we're going to calculate the speed here. So distance divided by time, so 20 divided by 2, we get 10 meters per second. And similarly for the last one, 5 as a distance divided by 1, so we get 5 meters per second. Alright, and already you have how he did the first calculation. Okay, this box is just to show up your working. Okay, now describe the pattern in these results. Patterns means the behavior or the relationship that you can notice from these results. As you can see, the height was 10 and the speed was 7.1. However, when the height was 20, now the speed goes up to 10. Now, when the height was 5, the speed goes down to 5. So there is a clear relationship between the height and the average speed, right? So as the height increases, okay, the average speed also increases. So we can simply fill out this by the word the speed increases. You can also mention goes higher or any other word that gives the same meaning. Okay, now moving to the next page, the diagram shows a distance time graph. Complete the labels using the words from the list. Time, speed, and distance. It's simple. Okay, now as you know, on the y-axis we always label it by the distance, while on the x-axis it is the time, right? And the gradient or the slope, okay, is the distance divided by the time, y-axis divided by the x-axis, which is the speed. Right? Now, a car moving at a constant speed, okay, which one do you think? A car moving at a constant speed? Now, whenever you have a straight line going up and starts from the origin in a distance time graph, so this means a constant speed. So now you get a constant speed in B, right? A straight line from the origin. Now a person running at a constant speed, then stopping and standing still, okay? So this is clearly shown up in diagram C. A person who is running at a constant speed. So you have a straight line, then you have another straight line which is perfectly horizontal parallel to the x-axis, means that the person stops for some time. Okay, now moving to the third question, person standing still. Okay, so this is clearly shown up in diagram A. Why? As the time passes, the distance is not changing more. So this means that the person is not cutting any more distance or any less distance. So the person is actually not moving. All right, moving to the next question, look at the distance time graph for a toy car. How far has the car moved after 4 seconds? Now we just need to use your ruler to have the perfect answer for this question, for this question or for these type of questions. Okay, so how far the car moved after 4 seconds? Now you have the given which is 4 seconds, 4 seconds which is the time. So you get at 4, draw a line. Okay, I will try to make it a little bit thicker. 1 second. Okay, so you draw a line from 4 seconds. This line will intersect. It will intersect the straight line drawn on the graph. Okay, now another line to intersect the distance axis, which is the y-axis. So here you can get 3. So how far the car moved at 4 seconds? After 4 seconds is actually 3 meters. Okay, now how long? How long he's asking now about time. How long it takes the car to move? A total of 6 meters. In this case, you are given the distance and not the time. So the distance given is 6 meters. You draw a line again at 6. Okay. Now the line is going to intersect at exactly point A. Okay. Draw another line from A to intersect the x-axis at the time, so you get 8 seconds. Okay, all right, describe what happens at the point labeled A. Now at this point we can never mention that the speed is increasing or decreasing, because this is actually only a point. A point means one number, okay, or one status. Okay, so at point A, what happens exactly at point A? The car actually is stopping, right? It actually stops, right? So the speed here is only 0 meters per second. Why we don't mention that at point A the speed is decreasing? Okay, because he is asking you about a point, a certain point. If the speed is decreasing, we can actually have the line like this, one line going downward. This is called that the speed is decreasing actually. Okay, but we do not say this, okay, because he's actually asking about a certain point and not an interval of time. He's asking about a specific second, which is at 8 seconds, or the 8th second, what happened at this specific second. So you just mention the speed at this specific point, and the speed at this specific point is actually 0. Why? Because already the car stopped. Okay, so we write here the answer. The car stopped. Right? Okay, here we go. Now you have 3 graphs, graph A, B, and C, and they are distance time graphs. Okay, so the straight line is showing you the speed. Okay, and since you have a straight line, so this means that the object is moving at a constant speed. You just need to calculate the speed for each diagram. Okay, now for A, it's simple. The speed is equal distance over time. Okay, now what is the distance here? Okay, you need to use your ruler again. Now the distance is actually 20. while the time you need to draw a line, okay, to intersect, to show you the time, to intersect the x-axis to show you the time. So we have distance, which is 20, and divided by 4, so we get 5 meters per second. Now, at B, same scenario, speed equals distance over time equal. So now the distance is clearly 18. But what about the time? Again, we need to draw a line from the endpoints. Okay, it's going to intersect roughly at 6. Okay, you can mention 6.1, it's okay, but 6 is also acceptable answer. So 18, which is the distance, divided by 6 equals 3 meters per second. Well, for diagram C, speed equals distance over time. Okay. Similarly, we're going to use the ruler. Clearly, the distance is at 16, while the time here is at 8. So 16 divided by 8 equals, I think it's 2 meters per second. That's great. Okay, how can you tell which speed is the fastest without doing any calculation? And you guys have a tricky way to do that, which is imagine that you are in an aqua park, okay, and you're going down a slide. So you are on the top of the slide. So imagine that you are on the top of each diagram, okay? Which slide do you think is the hardest one for you? So obviously it's A, right? Because A is the steeper. A is the steeper. Steeper means it has the bigger angle between the line itself and the x-axis. And the steeper the line, the faster the speed on it. Alright, so now how can you tell? So from the steepness of the line. The steepness of the line, okay, the more the steepness, the more the speed, or the faster. Okay, here we go. Okay, the next diagram, a boy races his bicycle along a track. Use this graph to answer the questions. How many meters did he travel in total? So now, again, use the ruler, please, to have the correct answer. How many meters? So he needs you to mention the distance or to calculate the distance. Okay, using the graph, the total distance traveled was simply 600 meters, right? Okay, what was the total time for the journey? Again, use a ruler. Okay, intersect the x-axis. This is the total time used to travel a distance of 600 meters. So you get only 180 seconds. Right? What was the average speed for the journey in meters per second? Okay, the average speed, now you have a changing speed throughout the journey. So you need to calculate the total distance divided by the total time. Total distance divided by total time, right? Equals total distance is 600 as we mentioned before, and divided by total time 180. So let me just calculate it using my calculator. 1 second, please. 600 divided 180. So you get 3.33 and the unit is simply meters per second. Alright, so I'm making a pause now. This is the first part of answering the homework and we're going to record another new video for the second part. Thank you very much. See you soon.